Here begins the transformation, where heavy machinery confronts the relentless soil of the Mexican desert. A Caterpillar D8 bulldozer initiates the process, aggressively removing the compacted and arid top layer of soil. Nothing stands in the way of progress. The massive steel blade effortlessly crushes tight clusters of cacti and hidden rock formations that would obstruct cultivation. Beneath the immense weight of its tracks, hard clods of earth are ground into fine powder, preparing the necessary texture for root penetration. Precision is fundamental. A laser receiver mounted on the tractor measures the slope of the terrain with millimetric accuracy, ensuring optimal water flow later on. Instantly responding to the laser data, the hydraulic system automatically adjusts the blade height, sculpting the exact grade required for drainage. To break the ancient hardened layer, a subsoiler drags heavy shanks through the ground, opening trenches 1 meter deep to allow future roots to penetrate. It is followed by a disc harrow, whose rows of concave metal plates slice through the loosened soil, further refining its structure to create a uniform seedbed. As the machines work, they leave behind long, undulating trails of red dust, marking the progress of civilization across the arid desert expanse. Modern agriculture relies on data. Satellite GPS systems guide the layout, marking perfectly straight rows with centimeter precision. A specialized trencher excavates a clean, narrow trench through the sand, preparing the underground artery that will bring life to this dry land. Workers manually distribute large-diameter PVC pipes along the trench, preparing the materials for the backbone of the irrigation system. The joints are permanently fused. A special solvent cement is applied to the connections, chemically welding the PVC segments into a single leak-proof conduit. At the water source, complex filtration banks and air purge valves are installed. These are the kidneys of the system, preventing clogs in the delicate drip lines. Field preparation enters its final phase. A tractor equipped with a specialized bed shaper aligns with the GPS markings to begin forming raised beds. Steel blades gather loose soil from the sides, pushing it inward to form a perfectly elevated ridge 30 centimeter high to facilitate drainage and root growth. Simultaneously, a roll of drip tape unwinds from the rear. This thin hose is the lifeline of the crop, designed to deliver water directly to the root zone. The tape is injected 5 centimeters below the soil surface, buried deep enough to stay cool and protected, yet shallow enough to hydrate the seedlings. In the same pass, a roll of black plastic mulch is firmly stretched over the newly formed bed. This layer prevents weed growth and retains valuable moisture. Angled wheels press the edges of the plastic into the furrows, ensuring a hermetic seal against the wind and anchoring the mulch firmly to the soil. Immediately afterward, rear discs throw a layer of soil over the tucked edges, burying the plastic perimeter so it cannot be torn away by desert storms. The result is a geometric marvel. Rows of black plastic stretch for kilometers, shining under the sun, transforming the chaotic desert into an organized production plant. Field workers walk the rows, checking the mulch tension. Any loose spot or tear is manually corrected to ensure the microclimate remains sealed. The irrigation system is activated for a stress test. Pressure increases in the pipes, checking for leaks before planting a single seed. Beneath the black plastic, invisible to the eye, water begins to seep from the drip tape, creating a cool, moist zone within the hot desert sand. Meanwhile, in the climate-controlled nursery, the cycle of life begins. An automatic seeder deposits individual watermelon seeds into prepared polystyrene trays. A thin layer of peat is sprinkled over the seeds. This light cover keeps the seed moist and allows the delicate sprout to emerge. The trays are moved to the germination room, where an automated misting system envelops them in a humid fog. 48 hours later, the magic happens. The first pale loops of watermelon sprouts break the surface, lifting the peat in a display of pure vitality. Under controlled light, the seedlings develop their first true leaves. They are hardened to build resilience, preparing them for the harsh reality of the desert field. Transplant day arrives. Trucks loaded with trays of young plants head toward the prepared fields, a caravan of green against the sand. In the field, workers quickly transfer the trays onto the transplanter racks. Speed is essential to prevent the roots from drying in the wind. The transplanter sets into motion. A spiked wheel rolls over the plastic mulch, punching precise, evenly spaced holes to receive the new plants. Mechanical fingers or gravity-fed cups gently deposit the root ball into each hole. It is a delicate operation performed at industrial speed. Immediately behind, angled press wheels tighten the soil around the root ball, eliminating air pockets and ensuring immediate soil contact. The transformation is radical. Thousands of bright green seedlings now dot the long black rows, standing out against the golden desert sand. To support this growth, nutrients are not scattered, but delivered with precision. In large tanks, a customized fertilizer cocktail dissolves into a nutrient-rich solution. High-pressure pumps inject this solution directly into the main water line, ensuring every drop of water carries the fuel the plants need to thrive. Out in the field, the mixture drips exactly where it matters. Not a single drop is wasted on weeds or empty sand. Powered by nutrients, white absorbent roots explode into the loose, moist soil, anchoring the plant and beginning absorption. Above the surface, the response is visible. The plant emerges from the hole and its vines begin to lengthen, searching for the sun. Perfection is the goal. Workers patrol the rows, detecting any failures and manually replanting to ensure 100% field occupancy. Between the plastic beds, nature fights back. Weeds sprout in the sand, but a cultivating tractor passes between them to keep the furrows clean. Sharp blades cut just below the surface, severing weed roots without disturbing the nearby watermelon beds. The plants are now established. The vines branch aggressively, marching across the black plastic, absorbing heat. To prevent strong desert winds from rolling and damaging the vines, workers secure them with stakes, guiding them to grow in the optimal direction. Soon, individual plants merge. Large lobed leaves completely cover the bed, creating a solar panel that fuels fruit production. The reproductive phase begins. In the leaf axils, the first bright yellow flowers open to the morning sun, signaling readiness. Watermelons cannot self-pollinate effectively. Trucks arrive carrying millions of contracted workers, honeybees essential for the harvest. Hive entrances are opened. Immediately, thousands of bees surge out, orienting themselves before heading to the crop. A forager lands on a male flower, collecting golden pollen on her legs. This is the first half of the crucial transfer. The bee flies to a female flower, distinguished by the tiny fruit at its base. As she feeds, she deposits the pollen, completing fertilization. At a microscopic level, pollen grains adhere to the sticky stigma, triggering fruit growth. Mission accomplished. The petals wither and fall, having fulfilled their purpose, redirecting all energy to the swelling ovary below. The tiny fruit begins to expand rapidly. In just a few days, the fertilized ovary transforms into a recognizable miniature watermelon. It reaches the size of a chicken egg. At this stage, the fruit is vulnerable, perfectly formed and covered by soft protective fuzz. Agronomists monitor the fruit set rate. Too many fruits per vine mean small watermelons. Too few, wasted potential. It is a numbers game. To guarantee premium size, workers thin the crop, removing deformed or excess fruits and channeling the plant's energy toward the best candidates. As the fruit enters the bulking phase, water demand skyrockets. The irrigation schedule intensifies, pumping volume into expanding cells. The characteristic appearance emerges. The fuzz falls off, and the rind develops its two-toned green stripes, a genetic barcode of the variety. The desert sun is relentless. Resting on black plastic, the fruit can literally cook. Management is crucial to prevent heat damage. Workers perform fruit turning, rotating each watermelon to ensure the underside does not yellow prematurely or rot. By shifting its position, the rind develops a uniform green color, increasing market value and aesthetic appeal. To prevent sunburn that ruins the flesh, workers cover exposed fruits with straw or pull vines over them to provide shade. Growth is explosive. The fruit increases in weight to 3 and then 4 kilos, pumping water and sugar into its structure every hour. A natural waxy layer or bloom develops on the rind. This dusty coating helps regulate moisture loss and protects against pathogens. Technology joins tradition. A manual sensor probe is inserted into the soil to verify that moisture levels are perfect for the final filling stage. It is time for the sugar push. The fertilizer blend is adjusted to increase potassium, the element responsible for transporting sugars to the fruit. The plant signals the end of the cycle. Older leaves near the base begin to yellow and wither as the vine diverts its last energy to the fruit. The watermelons reach their maximum potential, weighing an impressive 8 to 12 kilos, heavy, dense, and ready. Quality control is relentless. A technician sacrifices a sample fruit, cutting it open to inspect internal structure and color. A drop of juice is squeezed onto the prism of a refractometer. This device delivers the definitive verdict on sweetness. Looking through the lens, the blue line crosses the scale at 12%. It is a perfect Brix reading, guaranteeing a sweet and crisp flavor. Experienced harvesters verify with a knock. A hollow, resonant sound confirms internal integrity and readiness. The final visual cue is the tendril closest to the fruit. When this curled pig's tail turns brown and crispy, the connection to the vine is complete. Harvest day begins at dawn. A convoy of heavy trucks enters the field, headlights cutting through the early morning mist. Dozens of skilled harvesters spread across the rows. It is a massive, coordinated effort requiring speed and endurance. The lead cutter moves quickly. With a single precise motion, the knife severs the thick green stem, releasing the fruit from the vine. The fruit is flipped, revealing the creamy yellow field spot, the final confirmation of maturity. A white spot would mean it was picked too early. Strength is required to handle these giants. The worker bends and lifts the 12-kilo fruit, preparing to throw it down the line. The watermelon becomes a projectile, tossed through the air with expert ease to the next person in the chain. Soft hands, firm grip. The receiver instantly absorbs the momentum, catching the heavy fruit without bruising it. This is the throwing line, a human conveyor belt moving thousands of watermelons from field to truck at a rhythm rivaling any machine. A synchronized human chain moves the harvest efficiently, passing the heavy fruit with expert timing. The final destination in the field is the harvest bus, where skilled receivers ensure a safe landing. Inside, rubber padding protects the rind, while the load is meticulously organized. Layer by layer, the bus transforms into a mobile warehouse of fresh product. At full capacity, the transport unit begins its journey out of the furrows. Logistics are flawless. As soon as one truck exits, another reverses in to maintain the pace. Heavy wheels lift desert dust, marking the transition from field to plant. Hundreds of tons of fruit arrive daily at the packing facility, the heart of the operation. Forklifts work tirelessly, feeding processing lines with harvest containers. A container tipper gently tilts the load, using gravity to transfer the fruit without impact. Water acts as both cushion and preliminary cleaner, keeping the heavy fruit suspended. A gentle current guides the product toward the main processing line. An inclined roller conveyor gently lifts the fruit from the tank, transitioning from water to air. High-pressure jets remove soil and sand. Soft rotating brushes ensure every centimeter of rind is polished clean. A final disinfecting rinse eliminates surface bacteria, guaranteeing food safety. High-speed air knives remove moisture, preparing the surface for labeling. Dry and clean, the fruit enters the technological heart of the grading system. Advanced optical systems scan the entire surface instantly, detecting even the smallest imperfection. Defective fruit is immediately identified and removed by automated paddles. Simultaneously, electronic load cells measure weight to the gram for precise classification. High-speed applicators shoot adhesive brand labels onto each passing melon, a consumer-ready seal of quality. Sorted by size, the fruit is diverted down specific ramps toward packing stations. Human hands perform final packing, ensuring optimal distribution in containers. Durable pallets and triple-wall cardboard bins are built to withstand the journey. Protective paper sheets cushion the boxes, preventing friction damage. Once filled, containers are secured with straps to guarantee stability during transport. Finished pallets are immediately moved into the cold chain. Inside, the environment changes instantly. Rapid cooling preserves freshness and texture. Precise climate control reduces internal temperature to the optimal storage range. Each pallet is labeled with a unique barcode, ensuring total traceability from field to table. Refrigerated trucks reverse into sealed docks, maintaining cold chain integrity. The bridge is extended. The dock leveler creates a perfect path for loading. Forklifts execute the final loading step, filling the trailer to maximum capacity. A final transport temperature check ensures the cargo survives the journey. The doors close, the security seal is placed, and with the harvest secured, the fleet disperses toward distant markets. Across the vast Mexican desert, the journey continues through the night. Back at the origin, the cycle of life turns. Harvested fields lie silent. Machinery returns, not to harvest, but to restore the land. Shredders break down plant matter. Organic material is reintegrated into the soil, enriching it for the future. Infrastructure is carefully dismantled. Irrigation lines are removed for recycling. Workers organize used materials, leaving nothing behind. Specialized implements lift and roll the plastic mulch, clearing the land completely. Agricultural residues are transported for recycling, closing the sustainability loop. Silence returns. The desert regains its stillness, waiting for the next cycle. The sun sets over a season of hard work and abundance. Beneath a blanket of stars, the land rests. But the agricultural cycle is eternal. A new day brings the promise of the next harvest. Preparation begins immediately. Heavy machinery opens the path for future growth. This is high-tech agriculture, an unceasing pursuit of efficiency and sustainability. It all begins again with a single seed: water, soil, and sun, the ingredients of life.